My name is Vince Matev. I'm a Partner Alliance Manager at SUSE. I work with our SUSE Edge technology partners, and I support the development and growth of the ecosystem as a whole. We have a slight change in the speakers. We were supposed to have a colleague from Bosch Digital today to talk a little bit about the proof of concept that we did with them. Unfortunately, he couldn't make it, but my colleagues who've been also involved in the proof of concept, Peter Dimov and Atanas Dinov, will talk a little bit more about what we did together with Bosch Digital. And yeah, hopefully we'll give you some food for thought for industrial IoT use cases, how you can approach them, how you can leverage our SUSE Edge stack to enable this. Before we jump into the POC, I just want to highlight a few things about how we approach the edge market in general. And you can hear a lot more about our edge strategy from various sessions that we have throughout the day. Also, tomorrow morning, we have a keynote by our general manager, Keith Basil. So feel free to visit that as well. When we talk about edge, the reason we see it as only just getting started on that exponential growth is because of not because that customers don't already have edge deployments. On the contrary, there are many customers that have been doing this for dozens of years. What's changed for them is that now they are at the gate of having to modernize that infrastructure that they manage, having to rely on perhaps cloud-native concepts that they may not be too familiar with, and having to really work on scenarios where you start to see blurring between operation technology, legacy operation technology, and information technology. So we have these type of customers who are also kind of approaching edge from this new perspective. And of course, we have the other type of customers that are just getting introduced to edge as a whole, as a means for them to unlock additional business value, perhaps just work on edge deployments that can help them gain more insights about their business, how they can do business together, how they can potentially monetize data that they haven't necessarily been able to monetize until now. So that's the view that we share at SUSE, and that's very much the same view that analysts share as well. If we take a look here on the right, for example, Gartner are saying that more than 50% of the enterprise managed data will be created and processed at the edge by 2025. And yeah, it's coming up fast. So when we look at edge computing, so we have the traditional centralized infrastructure, data center type of deployments, public cloud type of deployments. This is not what edge computing is. As we move out of the data center, as we start to see data being processed closer to the user, closer to the source of the data, this is what we refer to edge. And we divide it into three distinct categories. Near edge is usually where we have communication service providers, so telco operators, internet companies, cable companies, etc., being kind of closer to the data center, but still having these edge-specific deployments. We do have an offering here that's called SUSE Adaptive Telco Infrastructure Platform, and there is a session coming up tomorrow afternoon that's going to go deep dive on our telco purpose-built platform. As we go into the far edge, this is where we start to see various kind of deployments, both in terms of size and type of deployments, and this can be anything from small form factor devices, like embedded devices, to really heavy devices and data center type of devices. It's a big list of hardware and something that we need to take into consideration as we start to design these edge environments. When we talk about far edge, here we talk about use cases: retail, manufacturing, public sector, healthcare, and then as we look into the tiny edge, this is really the domain of industrial IoT and something that we're gonna talk about in a minute in terms of what we did with Bosch Digital. So here we have all of these peripherals and sensors and cameras that have to be first discovered and then onboarded into these edge deployments so that we can manage them more effectively. And as we talk about challenges with edge deployments, the main challenge we are solving with our SUSE Edge stack is really how do you manage all of these hundreds and thousands of devices at scale in an automatic fashion. Also, when we talk about data, really data generated at the edge, it still has to be treated as enterprise critical, similar to the data being managed at data centers and in the cloud. And the stack that has to manage that data, it has to provide enterprise-grade security to do that. So this is another very important area where we are investing a lot of our engineering resources to make sure that we have an end-to-end secured stack. Especially considering you have all of these hundreds and thousands of devices that exponentially increase the attack vector. Whenever you have a critical vulnerability in one of these devices, this can easily pass on to other devices if it's not checked and secured. And also, our customers and partners rely on SUSE to provide architectural design guidance and be a trusted advisor when we go into these edge deployments. So they naturally have to rely on the SUSE open source technologies, and we encourage partners to adopt these open source technologies and protocols. And last, I wanted to briefly touch on far edge and tiny edge in the context of industrial IoT. So when we talk about the SUSE Edge stack, it can run anywhere from like small form factor devices to big data center grade servers, and that's what we call the far edge. This is where our SUSE Edge stack runs. But then we have all of these industrial IoT devices which are far too small for us to deploy Linux, let alone Kubernetes. But our stack communicates with these devices, with the firmware of these devices, so that we can discover them, onboard them, and be able to ask for data coming from these devices, so that then this data can be analyzed, processed, and potentially businesses can gain insights from that data. Yeah, so here on the picture we have, as an example, a small pressure sensor connected to the network, and we leverage the SUSE Edge stack to onboard that device. And now I'm going to pass it on to Peter to talk a little bit about the work we did with Bosch Digital. Yeah, take it away.
Hello, everyone. And again, thank you for joining. My name is Peter Dimov. I'm director of the Bulgarian office of SUSE and also part of Business Critical Linux. So before I dive into that, I'm going to talk a little bit about how we came to build that POC in the first place. So we had a great relationship with Bosch locally. And we've been talking like, how can we interact better? What can we partner on? So we went to this small startup doing robotics manufacturing in Sofia, because the industrial was kind of the touching point between the two companies. And they came with direct problem. We're manufacturing robots. We know everything about robots. We don't know anything about infrastructure. And we thought you, the big guys, can help us out. Because our customers really want a complete solution. They don't want just to ship a robot and deal with it. So who does? And thus, we had to come with an architecture that can support this. And normally, when we're talking about the edge and IoT, what that looks like for the customer, we have the devices, then some magic happens, and all of a sudden we can run that on our machines or our phones, and we can play with it. But in reality, what we really need is actually device management, device connectivity, digital twins, and I'll talk a little bit more about those in a bit. And that's how it actually looks in the back. We have the Eclipse Foundation, and here I can also mention that we wanted to do everything open source. And we found that Bosch have their open source stack as well in the Eclipse Foundation. So for the device management, we used Canto. For device connectivity, Hono and Mosquito. And for the digital twins, Ditto. And all that running on Slim Micro and K3S. And in the future, plans probably secured by New Vector as well. So why do we need the digital twin part? And that's really the most interesting part for me. Rather than the device management, there we are enabled to collect all the data and telemetry, and we now know how important is that for predictive maintenance, especially in the industrial use case. But the digital twin is another source that we can use to control all of our devices, have their digital representation in a controlled environment, but we can also use that to generate additional data if we want to train models or to forecast what will happen with the actual devices. This is a bit more deep dive on how the whole thing is connected together. I'm not going to go really deep in technical devices as Vince promised earlier. I know it's the last session for the day, so I'm going to keep it sweet and simple. And with that, actually, I'll pass that hard job to Atanas to go into the nitty-gritty and tell more about the whole reference infrastructure.
Thank you, Peter. Hello, everyone. Why did we go back so many slides, though? All right, here we are. Now, having software to manage IoT is great. However, while it is great, it still needs an infrastructure to run on. This is where SUSE shines. This is where we come in. Peter already mentioned that we have Hono for device connectivity, we have Ditto for the digital twins, and Canto overall as the management platform. However, all of those are running on top of Slim Micro. Now, Slim Micro, while it is great, it is exactly the use case for this POC that we built in this collaboration. It allows us to have a minimal footprint. It allows us to have a transactional-based operating system capable of running Kubernetes and any application workloads, which are the main essence of what we see on this slide. Now, Kubernetes is obviously managed by Rancher here in this example, and the distribution that was chosen is K3S. K3S is obviously a widely known Kubernetes distribution, which is great for it being a lightweight, a single binary, which is able to just run in few seconds. It is weird because I've seen this POC live. The robotic arm is something that everyone here has to witness with their own eyes in order to really appreciate how well this was working in practice. Now, when it comes to SUSE Edge in general, just because this is an edge case, that would be this would be considered an edge case, just because all the data is generated and processed on the edge device. Here we can actually see the whole SUSE Edge solution in practice. This is something that you may have already heard about in our previous presentations, our previous talks. We have technology showcases about this as well. However, SUSE Edge is a solution integrating a plethora of tools and solutions into a single, fine-grained, and seamlessly integrated platform which is able to host any sort of containerized applications. We have the operating system, which we already mentioned, Slim Micro. We have the two different Kubernetes distributions, K3S and RK2. We have their manager in the case of Rancher, which makes it easy to manage a large scale of clusters in large scales, as well as some additional components. For example, Longhorn for this as the storage engine, New Vector as the container security engine, providing us with zero trust functionalities. And we have also other tools that are well integrated and tested that we provide in the SUSE Edge platform. Now, something that we have to mention here is that, again, while Slim Micro is great, the bare bones Slim Micro is something that maybe not all of our clients are looking to adopt. This is where we have developed a tool called SUSE Edge Image Builder, which is something that I've already talked about in a previous session. So if in case you missed that, please check out the recording. I already see familiar faces here who attended it, so I won't dive that much deep into it. But Edge Image Builder is a brand new product developed by the SUSE Edge team, which was just created last year, at the end of last year, and just went publicly available. It allows you to feed a bare bones slim micro image, use some additional configuration defined in an image definition schema, and once the Edge Image Builder does its magic, the output is an operating system image ready to be deployed across many different nodes, across many different Edge environments. The main strengths here being one single operating systems, many deployments. With that, I can ask you, for whoever has missed the technology showcases, to do so tomorrow as well, just because we'll be also presenting and demonstrating Edge Image Builder on site downstairs. And for those who missed recording, again, to please check out that recording. Thank you for your attention.